Wow. That's pretty good.
I just want to drop it right off, use our 0 angle.
Having a hard time telling if I'm perturbing it or just chasing it.
It's always going back to the center. Yeah, it stabilizes back to the center, right? So it's already moving one direction when you poke it more.
It's a little bit too slow.
Okay, you want to show us what angle it can do off axis now?
Yep. Start there. I guess that's like 6.5. A little more. Try a little more. I think we're pretty much at the limit though. Yeah. Let's go 10-ish. I don't really know. Yeah. Around 5 or 6 figures. Yeah, I went.
Okay, so you want to try perturbing it with clay now?
Yep.
Okay, so what's the mass of your pendulum?
Are you including the rod or not the rod? The axis.
Just the pendulum.
Just the axis.
Yeah, sometimes you did a bigger tank.
70.
70 grams? Okay, so take about 70 grams and put it at the top of the plastic.
I know where it is. I just noticed this.
How does it know to turn around and come back?
We have a rotary pull over here, tracker position, up to our...
And so you just kind of keep it, like I mean it goes out so far and suddenly it comes back?
Yeah, it's balancing over here instead of in the center because the weight of the plate is exactly our triangle. But yeah, it's trying to keep all the parameters, right? So as this goes up, the curve position parameter builds up until eventually it's on a lean back and frees back. Yeah, the problem is right now, like, it drifts a fair amount, but if we increase cart parameter more to keep it in a narrower range, then when we get to the size, it runs back way too fast, so we can't catch it.
Looks like it just can't quite catch up on some of them.
Yeah, it really depends. If it's like it's kind of in the middle and you impulse it, it's good. But if it's on the outside at all and you impulse it, then it's already off and it won't catch up at all.
Okay, so how much weight did you put on?
70 grams. Yeah, 70 grams. Yeah. Which is the mass of the pendulum and the washer on top.
So what did you do in MapleSim?
We have an L2R solver. So we just added the mass to our system up here and ran the L2R solver. Output new parameters and turbine.
Very nice.
What about off center? Off vertical?
Off vertical?
Yeah.
I just... Oh, recovery?
Yeah, let's see if we can get it going.
Okay.
Were there big changes in your parameters?
Not huge, but
Enough, do you think it would
enough.
make a difference?
Yeah, definitely a difference. I think it would be better with the original parameters, really. But
Really?
yeah. Well, closer, somewhere between the two parameters. Like I think it over exaggerates kind of.
It's about the same as before as far as recovery is concerned.
So we were about 5 degrees over there.
Yeah, we've been tracking with the SCI, so we usually get around 5 or 6, depending on our parameter set. It's really dependent on how you use your hand too. The manual says to recover from an impulse, a magnetic impulse. When we did our testing, we based it on, actually I don't know if this is the right way yet. An impulse like this, so you impulse it, let it recover. Not like a continued, so.
The continuous force is the sum of impulses.
Yeah.
When I bring it up there, I'm just trying to see if I can get it to react and respond.
Yeah. Oh yeah, like I was just, like if we actually impulse it,
it didn't like that one.
Didn't like that one, but it does recover a little better from like a one impulse than from a continued one. And other than that, the parameters are a little better, so we should really get a better recovery. Okay, ready? Test that. Sure how much that was? 8, 9? Not quite 7.
Keep going. Further.
Going?
Further.
Yeah, well, anyway, that's not really. I was doing it before. I don't know what thing.
Could be a little better, but I guess you model it so that it's at the top, not so that it's here.
It's a little more than a quarter.
You do 3/4 of the above.
Thanks for not doing that at mass again.
Unless you think you can show something better.
They'd be the same, yeah.
Yeah, I mean, so I underestimate the amount of time it would take. So
Yeah.
So if people don't, if you think you've shown us your best stuff, then we're willing to move on. And
Yep. Is there any more questions about how we did our system?
We've seen everything.
I thought that something that would be self-controlling. Because like, if it's here, it'll naturally, like, because the problem with the straight track is it might run out of track. And the problem with
On my belt?
like a circular track, it'll, the wires will get tangled.
no, I don't have any.
This one,
It's not like you're doing the right stuff. You've
goes
got
too
the
far
LQR,
here,
you've
it'll naturally come back.
parameters that you throw into the tech to get calibration.
Balancing
Yeah, we calibrated our
it'll naturally
parameters
fall back.
theirs.
So how many calibration?
Based on experiment, basically. So like what our number of units are in controller units are obviously a lot different than that, right? And then also calibrated with the factors because they weight the factors slightly differently.
Well, the first thought I had was that
Like you
track
measure
would go
the
like this
distance
and
of
then
travel.
Yeah, the distance of travel and how many finite numbers difference that is, like the range, and then convert that to based on the length, so like units per centimeter. So our units is like
Do you need like a calibration? How many?
for the torque calibration we just did straight scaling. So like we took what order of magnitude we wanted and just scale it down. So we didn't put actually
So
calculate.
just kind of a guesstimate that it kind of works, so you use it.
Yeah, well we know what kind of order of
here it's
magnitude
harder to
numbers we need
stabilize,
based on like 2.5
like if we
for our pulse width
flip it around,
maximum.
it's harder to
So if you do,
stabilize.
a
It can recover much
simulation
more,
and it says increase the
right?
Yeah,
Down
and then it'll
here-
scale up
Down here, you
proportionally.
don't recover as
you
much,
increase
but
it by
it's much easier to
50%,
stabilize.
50% bigger. And
Yeah, like it'll put the exact
Because,
numbers because we have them all scaled already. So
you
had a mass
here, like,
yeah, we just have them all scaled already. So you just
can't recover.
very good.
But on the top, once it gets to the tangent, it turns